Hello friends, today I'm going to solve LeetCode problem number 1544, make the string great. So we are given here a string. It consists of lowercase and uppercase English letters, and we need to find two characters such that one of them is a lowercase character and the other one is an uppercase character. And if such character exists, we find them and then we remove those two characters from the string to make the string good. So basically, in a good string, no two characters, one with no two adjacent characters, one which is in lowercase and the other one which is the uppercase of the same letter should exist. So for example, here in this code in this string we have small case e and capital case E, and both of them are adjacent to each other. So for this string to be good, we actually need to remove these. So we actually need to remove these two characters from our string to make this string good. So how could we solve this problem? Let's see. Um, so, um, One way to solve this problem is we start from an index I equals to 1, and then we check is we check I and the character at I plus 1, so which is 2. So we check the character at 1 and character at 2, and the ASCII code of so the ASCII code of a small case letter and the uppercase letter, the difference is equals to 32. It's always 32. So for small case letter A and uppercase letter capital A, the difference is 32. And we need to actually check if the absolute of these two characters is equals to 32 or not. Since small l and small e, these two are not uppercase and lowercase of each other, so this will not be equals to 32. So that is when we increment our count, we increment the value of I, and now my I is equals to 2 here. So my I is here, which is equals to 2. Now I check I and I plus 1 again. So I'm checking for I and for I plus 1. Is the difference equals to 32? Yes, the difference is equals to 32 here. So what I need to do, I need to remove these two characters from this string. So how can I remove this? I just split the string. So I just take splice this string. I just take the first character from starting from 0 to I, where I is excluded and 0 is included, and then I concatenate it with, so what, let's see, what should we need to concatenate it with. So this we are removing at index I. We will also be removing the character at index I plus 1, so we need to concatenate it character from index I plus 2. So I will concatenate from index I plus 2 to all the way. So we will use slice for concatenation, for slicing and then concatenating. So this is how we'll get our new string, which is then L E E T C O T E. And right now you see I is equals to 2. I is equals to, oh, actually it should be 1 basically, because we are starting from, it is a zero indexed array, zero index string. So I will be equals to 1 here. So I is still equals to 1. Now here you could see like we already have our string which is good, but still we need to check for each of the other characters as well. So we keep on checking for all the characters as well. And one thing to keep in mind is, well, this is not a good example to explain that thing, so I'll move on to the next example. So we also need to take care of few more things here. So let's start from our index I here, which is equals to 0. So we start from index I equals to 0, and then we check is the value at I and the ASCII value at I plus 1, the difference equals to 32. So since I is equals to A and I plus 1 equals to B, which is not equals to 32, so we increment our I by 1. So we then increment our I1 by 1, else. This is the else case. This is the if case. So we increment our I by 1, and then here again I is equals to small b and I plus 1 is capital B, and the difference, absolute difference of these two characters is equals to 32. So what are we gonna do is we are gonna splice the whole character, so whole string, and concatenate only the string, concatenate to get the good strings. So what I'm gonna do is I'm gonna splice from starting from it should be starting from 0 to I, where I is not included, and then from I plus 2, I'm actually slicing it, not splicing, I'm sorry, to all the way to the length of the string. So what I get here is now A, capital A, small c, and capital C, and my I is still equals to 1. My I is still equals to 1 here. Now you see, right, my I is equals to 1, but now here starting from index I equals to 0, I get one more characters, like two characters, which are again making the string bad. So I also need to remove these two characters. So how could I do that? One way to do that is to use recursion. So what I do is I call the same function again, and then start right from I equals to 0. So I start from I equals to 0, and then I again do the same thing again, and this time I'll remove A and capital A. Then my new string will be equals to small c, capital C, and then I again call the recursive function, perform the whole thing again, and then my new string becomes an empty string. And then while I perform the function, since now I should be less than as the length of as minus 1. And since I length is equals to 0, which means that this whole value is equals to minus 1, and I always starts from 0. So 0 is not less than minus 1, so basically we do not actually need a base case. We could just from this if condition only we get check for that, and then at the end we return our string. And the other way to do that is by using two pointers kind of thing. So one way is since I removed this character at index 1, right, these two characters, my resulting value was A, capital A, small c, capital C, and my index was at this position. Since I removed from this position, so what I'm gonna do is I'm gonna shift my value of I by 1. So I decrease the value of I by 1 at this point. So whenever I remove any character from an index, I always decrease the value by 1, else I just go to my else condition and increment the value of I. So let's see how we could actually solve this by using this recursion and this method. So using recursion, what I do is, for let I equals to 0, we are always starting from I, and I should be less than as length bias 1, and we are always incrementing I, and then we check if mat dot absolute value of as at index I and minus as at index I plus 1, these two characters, is equals to 32. If yes, then my new string becomes, I'll splice the string and my new string becomes as dot slice at 0 to index I, where I is not included, and then as slice at I plus 2, because I'm removing the character at index I and index I plus 1, so I'll start at index I plus 2, and then I'm gonna make a recursive call and then return the value returned from the call. At the end, I'm gonna return s. So let's run our code. Okay, so I did one mistake here. I need to check the character code at index I, not subtract the characters. So I'm gonna subtract character code at index I by the character code at index I plus 1. Awesome, let's submit this. Cool. So talking about the time complexity, the best case time complexity would be when there are no bad characters, so we will never go into this, we will never perform the recursive function in that case. So we are only the time complexity at that case would be O of n. But in case when there are some bad characters in the string, then we need to remove those. So in that case, we are making a recursive call. So we perform a for loop, and then we perform a recursive call each time we encounter the bad characters. So basically at that point of time, our time complexity would be O of n squared, and the space complexity, talking about the space complexity, since we are not using any spaces or any variables to store our result, but we are still making this recursive function call, right? And the recursive function call is stored on a stack. So the number of times we make the recursive function call, that the number of storages will be used. So the number of recursive function calls would actually never be greater than the length of the string, right? So the space complexity here becomes O of n. Now let's solve this using another method, that was by using I minus 1, reducing the I. So we just don't need to do any of those things. So what I do is I just subtract I, and I don't need this, else only I increment the value of I, and now see what's the result. Great, we are getting our answer. So in this case, the time complexity becomes O of n, because I'm only going through the for loop once, and there is no space is used, so the space complexity is O of 1. So this is the most optimized solution. All right, have a great day, guys.